I bought all good boards. This is my favorite cutting mat, and I fried this already. I bought a lot of batteries, not all of them survived. Do you know what is UPS? This is already becoming a destructive video. Don't try this at home, not at least at your home, except if no one can see you. Just don't. You coming with me? But first I will show how efficiently destroy cutting mat, battery and PCB. Knowledge is coming. Batteries wired in series will have their voltages added together like this or this. Batteries wired in parallel will have their capacities added together. And if you will be stupid enough to order this battery holder, it obviously connects batteries in series and it will output 16 volts. This is how I fried this PCB. So don't buy this, buy this. They're more flexible, you can just wire how you like. In this case, it's wired in parallel. So these holders are more flexible, I wired in parallel, so the voltage will stay the same. Only if you're smart enough to find difference between plus and minus sign. This is plus. This is minus. And sparks often means something is wrong. The wire was thin enough to melt after the first battery, so it destroyed less of the metric side. Imperial side is okay, that does not make me more happy. This was tutorial how to fry PCB and cutting mats. Back to the topic. This is Raspberry Pi 4, $35 tiny computer with operating system Linux. It is like Windows, but much better. Yes, it's possible to install Windows and start questioning my life choices. I need to have continuous power for this small computer from wall socket and from the battery. And I need something like UPS, not a postal service. Does someone still remember what is UPS? And very close to UPS are power banks. So I'm building power bank for Raspberry Pi. This is power supply for Raspberry Pi, 5 volts, 3 ampere. I spent hours on AliExpress to find PCB board for DIY power bank with 3 ampere output and USB Type-C, quick charge power delivery, power pass-through charging. And it's not a lot of them. This is the first smallest board. To make a power bank, solder plus and minus in parallel, add more batteries to increase capacity. I cannot give you model names because tada, they don't have any, even if they are from the same company. I will use numbers and I will show these web pages. Next, from TZT 5-star, has one more USB port, 3 ampere, super. This added a lightning port. I even do not know what all this means. Looks amazing, on paper at least. And the biggest board that I got has display and extra charging port. Output from 3 ampere and more. This one has different types, 65 watt and 2 for 100 watt with different capacity. I got this, it's for 65 watt. It will not start until it's wired like on the web page. And it will not start working until an extra jump start with power from the wall socket for 5 seconds. As I have different boards, it was more convenient to 3D print battery holders. I only ordered these connectors. This I'm printing holder for 10 batteries. I made holder for the battery separate from the holder for PCB in case I will need to print different holder for different PCB. These connectors I'm soldering parallel. After some tests I decided to use this board. I will explain later. This board has button on the side, so I made this button. Button works. glue, batteries, and the power bank cover is printed. It is charged. How long it can run Raspberry Pi for? I will run Stress NG application with these options. It will use all available cores and it will be hot. Very hot. It is still running and it is late. I want to sleep. Let's check in the morning. Good morning. Is it still running? Yes, it is still running. Do you want to test power bank? And it took 15 hours and 34 minutes. Power bank is empty. How long it will take to charge with 5-volt charger, and I can monitor power consumption. Come on, it's already night. I want to sleep. Finally, it took 9 hours on 5-volt charger. I should try it with other chargers, but this will be in the morning. Good morning. I had a dream that I'm running multiple raspberries on single power bank. How many raspberries I can run? That's what I'm doing today. You're coming with me. 2 raspberries are running and with Stress NG on maximum load, no issues. I have one more raspberry, it's 400. That should be identical in power consumption. Power bank can run 2 raspberries on maximum load, but if I even connect a USB keyboard or USB mouse receiver to the third device, it is too much. I can use only 2 raspberries on full load. Now, bad news. I talked about UPS at the beginning, but power banks was designed with mobile phones in mind, where each device has its own battery. Fast switch between wall socket and battery was not on the checklist. I will just show this example with lights. I'm connecting power and it looks like power bank is rebooting or switching very slowly. This and this PCB can switch faster, but it's still not enough. I will call this PCB better because it has more ports, but they're quite the same. I have tested power banks made by someone else, not me, and only one can handle connecting and disconnecting external power. This one. Maybe it has something special inside. Let's check. Only thing I see, or to be correct, 3 things. This power bank has 3 capacitors. Maybe it helps. I will order capacitors. Oh, no, I will order super capacitors. Super is better than not super. In my next video, super capacitors, Raspberry Pi, power bank, and the meaning of life. Coming soon. Subscribe. Bye. I really don't know what I'm doing.